Okay, now we're going to do energy today. Okay, and just before we do something with energy, okay, just remember, don't get momentum and impulse confused with energy. Okay, the relationship is, consider momentum and impulse as brothers. Okay, and you only go there when there is a collision. When there is a collision or there's an impact. Okay? Impact of something on something. Okay? Now, the unit of them are kilograms meter per second or Newton seconds. Okay? So make sure you only involving these two when there's a collision or there's an impact or there are or you say units like this in questions. Okay, so energy is different. Okay, energy is measured in joules. The unit will be joules. Okay, now 1 joule, okay, of energy is basically, if you're holding, okay, if I can do it, okay, if you're holding a kilogram, 1 kilogram mass, okay, 1 meter above the ground, it's roughly, uh, well, if just let me draw it. Okay, now if you're holding a kilogram, okay, mass a meter above the ground, you are applying 1 joules energy to it. Okay, there are different types of energy. We're going to do that later. However, just don't get confused with momentum. They are related somehow, but in year 12 in VCE we don't worry too much about the relationship between energy and momentum. They're more like cousins. For momentum and impulse, the brothers, and this is you you're only going to look you're only going to looking for them when there's a collision or impact. Right? Or you say this unit. Okay? Otherwise, stay with energy. Okay, the first thing we're going to start with is the kinetic energy. Okay, so we may did you may did that in year 11. Okay? Now, kinetic energy, okay, is the energy horse on a moving object. Okay, so if an object is moving, it has a kinetic energy. If an object doesn't move, if a object stays still, it doesn't move, then it won't have a kinetic energy. Okay, so kinetic energy can be calculated by half mv square, where m is the mass, v will be uh, your velocity in meters per second. Okay. Actually, the speed. Okay. Now, just let me do an example. Say if I have a block, okay, a block of wood or something. Okay. Now, say if it's 2 kilograms and it moves at a velocity of 3 meters per second. Okay. Since it since it is moving, it must have a kinetic energy. Okay. The kinetic energy will be just half mv square. Okay. Half times kilogram. Sorry. half times 2, okay, times 3 square. Okay, then you will have 9 joules. The unit is in joules. Okay, so also if you look at the equation, the unit could be kilogram times meters per second bracket square. It ends up kilogram meter square per second square. Okay, now they are the same thing. So one joule is same as this. Okay? Don't bother about figure out what they mean. So just stay, because the idea is, okay, the idea for units is, okay, if every time we're talking about energy, okay, I'm going to mention a unit of kilogram meter square per second square. It's just too much, and it doesn't make sense. So we make this. So we invented something called joules. We call this 1 joule, okay, of energy. So we have 9 joules of energy here. Okay, now, okay, now what happens is there's another. Just give me a second. Okay, now there's another type of energy. We call it gravitational potential energy. Okay, so it's energy. Okay, we hold against. Um, we hold. We use to overcome the effect of gravity. I show you an example here. Okay, so uh, give me a second. Okay, now say if I have this. Okay, so say we have a skater, okay, in here, and a giant comes around and pick him up. Okay, so as I pick him up in the air, okay, I need to use energy. Okay, and I need to use energy to overcome the effect of gravity. I'm holding it and pulling it against gravity. Okay, so the higher I'm holding it, the more energy I need to use. Okay, so the idea is if I release it, the energy will be released. So the idea is we call this energy gravitational potential energy. Okay, so it is calculated. For now, just remember for potential. Okay, so gravitational potential energy is calculated in mass times the gravity and times the height. Okay, mass times the gravity times the height. So if we look at the unit, okay, kilogram times meters per second square times meters, okay, it's going to end up kilogram meter square second square, okay, which is 1 joule. So it's a measurement of energy. Okay, so if you can, okay, if you look at the previous page, okay, they are the same. Okay, so okay, I gave you an example again. Okay, so if I'm, well, as example we did before. So if, say this is me, okay, say if I'm holding a ball, well, I'm holding something of 1 kilogram, okay, above the ground for 1 meter. Okay, 1 meter above the ground. Okay, now let's calculate the potential. Let's use gravity as 10. Okay. Now the potential energy used to hold this object on the air will be, okay, will be 1 times 10 times 1. Actually, that's 10 joules. Okay, so I made a mistake. Okay, in the introduction. Okay, now, okay, so this is called gravitational potential energy. Okay, just a different type of energy than kinetic energy. They are still energies. Now, well, let me show you one more example. Okay, so if we look at this simulation, I put down bar graph. Okay, now the idea is if you look at the tab here, okay, says potential energy. Say if, okay, I move this guy upwards, okay, the potential energy would increase. Okay, I release it, it will be gone. Okay, now just let me show you it there. Okay, potential energy, just have a look. If I move this guy, the higher I move it, means the more energy I need to apply to it against the gravity. Okay, so the more potential energy it has. Okay. Okay, now the next type of energy we're going to learn is called a work done. Okay, it has a confusing name, but I show you why. Okay, so by definition, okay, work done is measured in change of kinetic energy. Okay, but however, just remember that. Okay, but I give you an example. So if I have a elephant, okay, sorry about the drawing. Should be, yeah, I have a big elephant. Yep. Ah, okay, I call it an elephant. Okay, so if an elephant is pushing against a mountain, okay, the elephant is pushing against a mountain, and he pushes really hard, and the mountain stays still. The mountain doesn't move. Okay, so this is considered as no work done. Okay, so the work done will be 0. However, okay, however, if I have a no, say if I am here, so say this is me. Okay, if I'm here pushing a, say, no, just give me a second. Say I'm here pushing a pen. Okay, so on a table. Okay, say I'm here pushing a pen. Let's say it's just a paper box. I'm pushing a box to say I have a long table. Okay, now for 1 meter. Okay, because the box moved, I done some work. Okay, so I done some work. Okay, so work done is calculated by force times the distance, the horizontal distance traveled. Okay, now in this case, I could say that I did more work than the elephant because the elephant this time did has no work done, and I pushed the box over the table and I did more work than him. So to calculate this, so what I do is say I applied 5 Newton of forces and it travels 1 meter. So what I do is 5 Newton times 1 meter, then I have 5 joules of energy. Okay, the work done will be 5 joules of energy. Okay, so okay, in physics, okay, work done is referred as the change of kinetic energy. Okay, so when the elephant was pushing the mountain doesn't move, so the mountain doesn't gain any kinetic energy. So the elephant did no work on the mountain. However, when I was pushing the box moved, means the box obtained some kinetic energy, and it obtained 5 joules. So I have done 5 joules of work on the box. So that's the concept. Now let's look at the mass. Okay, let's look at the units. Okay, again, now I do this only to show you the units. So force is measured in MA. Okay, now look at the unit. I have kilogram and meters per second square times meters again. So I have kilogram meter square per second square. The unit equivalent to joule. Okay, actually equal sign equivalent to joule. So force times distance give you an energy. Okay, called work done.